Good morning, everyone. Today we have seen the proof of distance formula for 2D. Okay, this is a simple formula, but the proof is required some geometric analysis and the Pythagoras. Pythagoras. Okay, proof is simple, very simple. So what? Let's now find the distance between any 2 point P x1, y1 and Q x2, y2. I have already drawn this diagram. This point is P and this point is Q. If you cannot visualize it like that. This is xy plane and there is a point P and there is a point Q. Okay, P, Q. We have to find this distance. Okay, this is a xy plane. Now what is the construction is, make a perpendicular on x-axis from P and name it M. Okay, also from Q and name it N. Now can you tell me the distance between O and M? What is that? This is basically a x1. Okay, x1, because this is x1. And similarly, what is the distance between O and N? This is x2. Okay, this is x2. It's simple. This point is y2. Okay, this is x2. If you can't connect it like this, if this point is x1 comma y1, so this is x1 and this is x2, so this is x2. Okay, now let's find Mn. What is Mn? Mn is nothing but the difference between x2 and x1. This Mn is x2 minus x1. Okay, now this for x is completed. Now think about y. What is this? Let this point be a R. What is, say, let's P. What is the distance between P and M? The distance between P and M is y1. Okay, what is distance between the Q and N? This is y2. Okay, I hope you will understand this one. If this point is x1 comma y1, then we have to travel x distance here and travel y distance here to reach x1 comma y1. So this distance is y1 and this distance is y2. Now we have to find what is QR. It's also simple. What is QR? QR is difference between y2 and y. This whole is y2, this whole is y2, and this is y1. What is this? This is y2 minus y1. Now let's consider a triangle PQR. Okay, PQR. Sorry for overwritings. Say P Q and R. We have find Mn. Mn, this distance is always similar to x2 minus x1 in both the sense. Okay, in whole graph. So we get PR is x2 minus x1. This angle is right angle. Similarly, this is we get QR. This is y2 minus y1. Now apply the Pythagoras. What is Pythagoras says? PQ, that is hypotenuse square, is equal to PR, that is base square, plus height QR square. This is x2 minus x1 square plus QR is y2 minus y1 square. This is PQ square. So what is the PQ? PQ is square root of x2 minus x1 square plus y2 minus y1 square. This is a legendary distance formula for 2D. I hope this is simple. You connect it. Now let's see the main motive and main determination required for the 3D. Okay, if we work in 2D, we apply Pythagoras once. Okay, now let's what about 3D. I have drawn that diagram. This is simple. You can connect it. I have drawn a cube, or you say cuboid. Let's 2 point P Q. Okay, now let's visualize like if this is okay. You can label any axis, x, y, z. Okay, now here place this cube. This cube is here somewhere. Okay, let's connect it, please. This is important. Okay, this here. Okay, now let's see like this. This is a little bit confusing. This is, let somewhere a point is P and somewhere is a point Q. Now P and Q. Now I have to make a cube like this. Is a main principal diagonal from the bottom of cube to the top of the cube. Make it. Now can make it like that. Okay, this is simple. P Q. Now what is in 2D? Let's visualize. We have taken the differences of this of points. Okay, x2 minus x1, this distance, and this distance is same. When y, we take y2 minus y1. Now in 3D, let's say in 3D, we have to apply Pythagoras twice. Okay, twice. This is twice. Now let's take these triangles P, Q and R, and this is a 90 degree. Okay, I hope this visualization is difficult. How visualize this 90 degree? So you can think like that. Say this is a line and this is a line. If you can draw any line like this, this, this and this is 90 degree to this. Okay, and 90 degree also to this. So this is 90 degree. Okay, this is also a edge and this is also edge. You can also get it 90 degree. Okay, now see PQR. Okay, where is the right angle? Right angle is at R. P and Q. Okay, so forget this diagram. Now consider this triangle and R is 90 degree. Now apply the Pythagoras. What says Pythagoras? PQ square is equal to PR square plus RQ square. Okay, Now take another triangle, that is QRS. Okay, QRS, and this is 90 degree. Where is 90? S, Q and R. Forget about one, you can take any point, but focus on right angle. Okay, this is S. Now apply again Pythagoras. This is RQ square is equal to QS square plus SR square. Okay, now put that PQ square is equal to PR square plus RQ square, but we get RQ square is this one. Now label this one PR square plus what is RQ square? QS square plus SR square. Okay, I hope you can connect it and get it by applying the Pythagoras twice. And this is a diagram for taking a 90 degree. The visualization is that this is a perpendicular axis, and if there is some line, as you say, this one is, and this one is 90 degree to both x and y, so that's why this angle is 90 degree. The visualization is this angle is difficult, but you can imagine it. This is a obvious 90 degree, the angle between two edges. Okay, now so simple. Now what is PR? Okay, what is PR? Let's focus on PR square. We have PR square here. PR is a same line. Okay, same line, but if you take any, let's say this diagram. Okay, imagine this one. Okay, this is on what is, if this is x1 y1 z1, let's consider it only, say this is on x-axis, on x-axis. So if there is 2 points on x-axis, okay, say x1 and x2, what is the distance between them? This is x2 minus x1. Okay, simple, x2 minus x1. For x square we have take x2 minus x1 whole square for PR. Okay, let's say QS, let's say this is y-axis. Okay, this is y-axis, let's say, because x is already dead, we have to y and z. Now I have considered y. Okay, simple. Now if there is x-axis, this is y, let's say I have taken y, this is y. If there are 2 points y2 and y1, y1 and y2, what is the distance between them? This is simple, y2 minus y1, and there is square, so this is whole square. So let's this one. Okay, this is SR, this is SR. Okay, say SR, this line is parallel to z axis. Now this is become z, only left is z, this is z. See, this is a case where all distance between same. So if this is z, this distance, this distance, this distance, this one, this one, this one is also. Let 2 points on z, there is z1 and z2. What is this? This is simple between z2 minus z1 whole square. Okay, I hope you can got it. This, because this is a line on xz, xz, the difference is only in the y coordinate is changing. Okay, so we can get this. And what is here PQ is under root, sorry, PQ, not PQ square, only PQ here, PQ is under root x2 minus x1 square plus y2 minus y1 square plus z2 minus z1 square. Okay, this is a 3D proof of a distance formula. This is simple, but this is asked in interviews, and for depth analysis you can have to prove it simply. Okay, and in general we can also generalize this formula for nth dimensional. Okay, nth dimensional. This is a simple and beautiful proof for. I can see also some pattern, but I am not sure. You can confirm in my comment section. If there is 2D, I have applied Pythagoras once. If there is 3D, we apply Pythagoras twice. If there is a nth dimensional, can we apply Pythagoras n minus 1 at times? So this is a beautiful question. I don't have answer for this, but I will find and I will discuss with you. So this is simple proof of distance formula. You all know distance formula very well, but the proof gives you a confidence for how they came and what is the simple proof. Thank you. I hope